Mechatronic design is a set of tools that are quite useful for the development and validation of products and processes from a technical approach, which allow establishing quality features for development and obtaining data for validation. Due to the slow technological and industrial development of Ecuador, the lack of appropriate production of egg trays for transporting to meet the needs of the poultry sector and its consumers has generated the necessity to import this product to neighboring countries. This project aims to capture the phase of the mechatronic design of an egg tray machine. Providing quality transportation for fragile products and specifically eggs has been the reason for the development of several engineering designs, generating products that meet the requirements of consumers and producers of this important food. We have based our methodology on the engineering design process proposed by George E. Dieter in his book Engineering Design, which consists of the following main stages: concepts generation, concept evaluation, product architecture, configuration design. A QFD analysis was carried out taking into account the most important parameters demanded by the consumer. The results of CONO analysis are shown in the table, which the performance features provide better customer satisfaction. Here the black box level for the functional diagram of the design machine is shown. The main inputs, output and main function of the machine are identified, which in this case is the molding of egg trays. Level 1 of the functional diagram is shown, noting the necessary subfunctions for the operation of the machine. The inputs and outputs between each subfunction are also shown in detail, with which their interactions can be appreciated. Using the pub matrix and the weighted pub matrix according to the QFD and comparing it with the Moldica company located in Colombia, we obtain the concept corresponding to the figure. Once to find the system/subsystems, the process map with its inputs and outputs is made. As a first step for the development of the product architecture, the cluster of elements of a schematic diagram was elaborated, which is based on the functional diagram and it is shown in the figure. The interactions between the modules that make up the system are also detailed. The material selection was made using Ashby's methodology. It is very useful for optimizing the design phase based on the most appropriate selection of materials for the established applications. At the modeling stage, the 3D modeling of the egg tray machine was designed using SolidWorks software. Here are the different modules of the machine mentioned in the development of architecture: the control, rotation, feeding, molding and collection modules. The critical subsystems of the machine correspond to the pneumatic and electric. In the table you can see the sizing of the essential components of the machine. The finite element analysis of the critical mechanical components of the machine was made using SolidWorks and SAP 2000 softwares. One of the critical components of the system is the drum shaft, as it supports the drum and transmits power. The maximum shear stress for the drum shaft under a torsion load shown in is 10.64 megapascals. The maximum displacement that the structure presents under a load of 4 tons, which is roughly the weight of the machine, is 0.222 millimeters. The maximum value obtained for the von Mises stress for the 4-bar mechanism shaft is 161.5 megapascals, which does not exceed the elastic limit of cast carbon steel, which is 248.2 MPa, therefore the design is safe. Finally, the maximum von Mises stress on the Geneva wheel mechanism is 1.31 megapascals, which is below the elastic limit of the AISID2 steel, which is 1860 MPa, therefore the mechanism will work well. The concept generation stage, throw a valid concept. Yes, the concept validation stage, throw a functional diagram with the necessary parameters of the machine. Yes, in the product architecture, all elements have their respective function and interactions. Yes, in the product architecture, all elements have their respective function and interactions. Yes. Conclusions. The application of mechatronic design in product development allows addressing the technical part, quality and the voice of the customer in the design process, thus meeting the real needs of the sector, which is a significant advantage in the market. The CONO and QFD analysis don't have the same results in terms of priority features. The FEA shows that the design is well done. There are several ways to transform a continuous rotary motion to intermittent, but the Geneva wheel mechanism is selected because of its ease of design. The mechatronic design of the machine takes into account the sustainability of the molds. These are interchangeable and easy to recycle for the care of the environment.